All right, here we go. Just to recap to see where we're at so far for systems of linear equations. So we've solved by graphing, yes? And how many types of graphing methods do we know? 3, okay. Substitution method. And then from there we went to elimination, yes? All right. So our objective for today, I can solve systems of linear equations by elimination. Repeat together. 1, 2, 3. I can solve systems of linear equations by elimination. So we don't need a fair model today. I just want to recap a couple more things before I just close this lesson, because we're about to head on to applications, just word problems. Yay! So we did Frayer models, yes? And we had an essential question that you wrote for your summary, yes? All right. And we did example Q. We did example super Q. And then mega Q. Hold on. Okay. So we know how to eliminate, right? We're getting up to right there. So now check this out. Before I continue, I'm going to do example. Well, let me just continue with the next one. Super duper Q. Copy this one, please. Well, yeah, copy this one, please. Example super duper Q. Check this out. So in order for us to do elimination, once again, we need to, what are the 3 things that need to be true before we start eliminating? The constant needs to be isolated. All the variables and constants need to be aligned. And we need to have opposite coefficients on the variable that we're going to eliminate. So let's see, are the constants isolated? No, the top one needs to be by itself. What needs to be by itself? The 4, so I need to get rid of the y, so I subtract y, and I end up with negative y minus x equals 4. Did you see that? And then what eliminates, everyone? Bless you. The y. And do we know what to do from there? Negative 3x equals 9, and then solve for x. Are we there? Okay. Any questions for these type of equations? I mean systems. Okay. So, but what happens when we have example Michael Jordan Q? Copy this. 4x plus y plus u equals 15, and 2x plus y equals 9. So let's see the 3 things, prerequisites, bless you. Are the constants isolated? Yes. Is everything aligned? Yes. However, do we have opposite coefficients on the variables? No. No. Which one is close, though? The y. One of them has to be negative. Is that correct? Okay. So check this out. If I wanted to eliminate the y, I need to multiply either equation by negative 1. So watch. Times negative 1. So my new equation would be negative 4x. Yes? What else? Negative y. And what else? Equals negative 15, because I distribute to each of these. Are we there? And now, without using the top one, just these 2, what do we have left? Don't copy this. You're just paying attention. Check this out. This is negative 2x. These cancel, and we're left with negative 6. And do we know what to do from there? Yes. Okay. However, could I multiply the bottom one by negative 1? Yes. So if I multiply this by negative 1, what do I have? What's my new equation? Negative 2x. What else? Negative y equals negative 9. And then if we start the combination elimination, this is 2x. These cancel. What is 15 minus 9? 6. Are we there so far? Okay, now check this out. How about this? So that those two examples that we just did is eliminating the y, right? So think about this. What if I wanted to eliminate the x, though? What would I need to multiply this second equation by? Sorry, neighbor, please. What do I need? Who's got it? Luca. By -2, that is correct. Multiply by -2, that gives me -4x minus 2y equals -18. Does everybody see that? How we distribute, we get this. So now the x's cancel, and we're left with -y equals -3. And of course, from there we divide by -1, so y equals 3. Do we know what to do from there? We don't know what to do from there. We substitute either here and here the y value, and then solve for x, yes? Everybody there? All right, copy this example, the one we just did with -2, eliminating the x. I just wanted to show you the different ways of eliminating y first, but now eliminating x for that one. All right, let's continue from there. So I'm going to use the top one. I'm going to write 4x plus y equals 15. But instead of y, what goes there? 3. So then we write 4x plus 3 equals 15. Let me solve for that. -3 minus 3. 4x equals 12. Divided by 4. X equals 3. What's our point? 3, 3. Okay. How are we doing? All right? All right. So once again, the key is to remember that the 3 things that need to be present before we eliminate one of the variables. The constant needs to be isolated. What else? They need to be aligned. And what else? We need to have an opposite coefficient. Doesn't matter which one you want to eliminate, either the y or the x, but it needs to be opposites. All right? Now check this out. But what if we end up with something like this one? Write your utensils down, look up, please. Example, Teenage Mutant Ninja Turtle Q. Look at it. Could I eliminate the x? Could I eliminate the y? And they are aligned, the constants are by themselves, but now we have a dilemma because we can't eliminate. Check this out. But what if we treated these as denominators? If we have common denominator, one of them negative, one of them positive, could we eliminate that? Yes. So what would be a common denominator? 6. So to make this into a -6, I multiply times what? 3. And this one times what? No. I'm saying this one's already negative, so this one times 2. So watch. 3 times -2 is -6x. 3 times 3, that's 9y. And 3 times -15 is -45. Are we there? Now look at this one. That's 6x plus 4y equals -46. Can we eliminate from there? Yes. Everybody see that? Tonight's hopefully going to have a couple of these where you're going to have to find like a common multiple for either variable that you want to eliminate. But just remember, they have to be opposite coefficients. So our home plate for tonight is on page 309 only. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Yes.